Welcome to ChemTech Laboratory Tutorial. Today, we will be looking at the order of a reaction, the basis of the order of a reaction. Now, the order of a reaction is being determined for elementary reactions as the number of moles of each reactant that gives a product. In elementary reaction, we determine the order of a reaction as this. For example, if we have A plus B to give us C plus D, the order of the reaction will be 2 because 2 reactants is involved in the reaction. Also, in the elementary reaction, molecularity can also be determined just the way order of reaction is being determined. But the order of reaction of complex reaction are determined experimentally using rate 2 all over rate 1 equals to concentration 2 all over concentration 1, all in bracket raised to power n. So, the order of reaction, you look at the rate of reaction of experiment 2 all over the rate of reaction of experiment 1 equals to the concentration of the reaction of experiment 2 all over the concentration of the reaction of equation of experiment 1, all in bracket to the n. The n signifies the order of the reaction. So we are going to take an example to explain this order, how it's being calculated experimentally to get order of a reaction. So we are going to take this example to explain the order of a reaction. Like I said earlier, that the order of a reaction is experimentally determined for a complex reaction. So if you look at this example, the question says acetaldehyde decomposes when heated to give 2 products. This is acetaldehyde. It's heated to give us methane gas and carbon dioxide. And this reaction was done in 3 experiments. This table shows, the first column shows the concentration of the reaction of acetaldehyde, and the second column shows the rate of reaction for the acetaldehyde to decompose. In the first experiment, we have concentration 1.75 times 10 raised to the power minus 3 with the corresponding rate of 2.06 times 10 raised to the power minus 11. And this also is done for experiment 2 and experiment 3. The question is, determine the order of the reaction. So when you want to determine the order of the reaction, you go by the formula that says rate 2 all over rate 1 is equal to concentration 2 all over concentration 1. So what is rate 2? Rate 2 is the experiment 2 that shows in the table, and rate 1 is the experiment 1 that shows on this table with their corresponding concentration. So this table shows that is the concentration. Then the rate is, for the corresponding rate of 2 is 8.24 times 10 raised to the power minus 11 all over 2.06 times 10 raised to power minus 11. So we are going to press our calculator to know the value of the order of reaction. N is equals to the order of the reaction. When you tap your calculator, you see that 8.24 times 10 raised to power 11 divided by this will give us 4. And these two, when you divide them, it will give us 2 raised to